So here we're going to select one of 7 candidates. So we have 7 candidates. And we're going to select one to fill a position in the math department. And we're going to select out of 10 candidates, we're going to select 2 to fill 2 identical positions in the computer science department. And they also tell us that none of the candidates is eligible for a position in both departments, meaning when we are selecting these 2, it has to come from this pool of 10 and not from these other 7 candidates. And the question is, how many different sets of 3 candidates could we select? So the first part, the number of ways we can select one candidate for the math department, that's easy, it's just 7, because we're selecting from a pool of 7, we're only selecting 1. To find the number of ways we can select 2 candidates from a pool of from a pool of 10, this is a combination problem, meaning when we select candidate 3 and candidate 7, the order doesn't matter. So this is combination. So 2 spots can be filled 10 times 9, and then I have to divide it by 2 times 1. Or this is equivalent to what you would see in books 10C2 or 10 factorial over 8 factorial or 2 factorial. You'd see it reduces to the same. We can simplify this. So that's 45. So there are 7 ways I can select the candidate in the math department, 45 in the computer science department. And I'm going to be pairing these up, meaning I'm going to have M1, M2, M3 up to M7, and then I'm going to have similar pools here, C1, C8, C3, C5, and then I'm going to be matching these. So this goes back to the fundamental counting principle, which means if you can do this in 7 different ways and 45 different ways for the computer science department, then the total number of ways would just be the product. So the answer would be 45 times 7, which is 28, 315. So the correct answer is choice E.